Hi friends, welcome to the session. Fitzgerald's contraction postulate used to explain the negative results of Michelson-Morley experiment easily follows from the theory of relativity, that is the apparent length contraction. So these are the consequences of the Lorentz transformation, and the first consequence is the length contraction. For this part, to calculate the length contraction or to explain the length contraction, let us consider the two inertial frames, S and S dash. S dash is moving with a velocity v relative to positive x direction. The frame S is at rest. Let AB is the rod lying along the x-axis in a frame S, and the coordinates of the rod are the x1 and x2 of the ends of A and B respectively. Then the length L0 of the rod in the frame S is given by L0 is equal to x2 minus x1. Let an observer in S dash measure the length of the same rod if x dash and x2 dash are the coordinates of ends A and B of the rod at the same time. The length of the rod will be given by L is equal to x2 dash minus x1 dash. Now according to inverse Lorentz transformation, we know the inverse Lorentz transformation is x is equal to x plus vt by under root of 1 minus v square by c square. So for the coordinate x1, according to inverse law of transformation, that is x1 is equal to x1 dash plus vt dash divided by 1 under root of 1 minus v square by c square. Similarly for the coordinate x2, we write x2 is equal to x2 dash plus vt dash divided by square root of 1 minus v square by c square. Therefore, L0 is equal to x2 minus x1. So just substitute the value and take the subtraction. So L0 is equal to, this is the value of x2 and this is the value of x1. So L0 is equal to x2 dash plus vt dash divided by square root of 1 minus v square by c square minus x1 dash plus vt dash divided by root of 1 minus v square by c square. So by just rearranging the equation, we get L0 is equal to 1 divided by under root of 1 minus v square by c square is multiplied with x2 dash plus vt dash plus minus x1 minus vt dash. By simplifying this equation, we get L0 is equal to 1 divided by under root of 1 minus v square by c square into x2 dash minus x1. Then again simplifying, we get L0 is equal to L divided by under root of 1 minus v square by c square. Here x2 minus x2 dash minus x1 dash is nothing but L. So just take the cross multiplication, we get L is equal to L0 into square root of 1 minus v square by c square. So we can write, we know the value. So this term is at the numerator, so this term goes to denominator, we get the 1 by under root of 1 minus v square by c square. So 1 by 1 minus 1 by under root of 1 minus v square by square is nothing but gamma. So we can write gamma is equal to 1 divided by 1 root of 1 minus v square by c square. So L is equal to L0 by gamma. Here this length, which length? L, is contracted by a factor, that is 1 under root of 1 minus v square by c square in the direction of motion. This phenomenon is called as a Lorentz-Fitzgerald contraction. It is generally the result, the length measured in all frame of reference which are moving at a constant speed with respect to the frame in which the object is at rest will be shorter by an amount of under root of 1 minus v square by c square. So this equation shows that the stationary observer, the length of the rod placed in moving frame S dash appears to be contracted by the factor under root of 1 minus v square by square c square in the direction of its motion. The length at right angles to the direction of motion remains, however, unchanged. For example, a spherical body of diameter L0 will appear to be an oblate spheroid with diameter L0 under root of 1 minus v square by c square when moving with the velocity v to the observer. It follows the equation that an observer in the frame, that is the moving frame S dash, is in motion will also find the length of the rod lying in S to be observer by the same ratio, because v square occurs in the formula for the contraction which remains unchanged. If v is replaced by minus v, thus the contraction is reciprocal. If two identical rods are at rest, one in S and other in the S dash, each of the observer finds the other rod is shorter than the rod of his own frame. This effect is called as a Lorentz contraction. The length L0 is measured in the frame in which it is at rest is called the proper length, while the L small l capital L is the improper length. It must be noted that the contraction takes place only in the direction of the motion and is unaffected in all other directions. In other words, the shortening or the contraction in the length of an object along its direction of motion is known as Lorentz-Fitzgerald contraction. So there is no contraction in a direction perpendicular to the direction of motion. The contraction becomes appreciable only when v is close to the c. The contraction is reciprocal if two identical rods are at rest, one in S and other in S dash, of each observers find that the other is shorter than the rod of his own system. For the sake of convenience, just take the example, the person which is at stationary and observing the two events, one is the square and another is the circle. He seems that all are same size, but the person is in motion and observing same square and circle. He finds the square becomes rectangle and the sphere becomes ellipse. So this is the way of finding the observation. So reference frame at rest, he seems that all the shape and size are same, but the frame of reference is in motion and observing the event of the which is happening in the rest frame, he feels that the shape and size become changed, the length of the rod becomes shorter. These are the examples of the length contraction, and I hope you understand the length contraction. Thank you very much.